Calculus, video 31, more on the product and quotient rules. Alright, so just a couple little things we can do with the product and quotient rules. So, product rule, we've seen this a few times, it says, suppose that h of x is equal to f of x times g of x, two functions multiplied. Then we know that the derivative, h prime of x, is f prime of x, g of x, plus f of x, g prime of x. And that is the product rule. The question is, so that's what happens when two things are multiplied together. We use the product rule. The question is, what if three things are multiplied together? What if you have 3x squared times cosine of x times sine of x? Now you've got three things together. What do you do? A couple of options. You could consider one of them like combining two of these together and call that f of x, and then the third one's like g of x. You could kind of combine two together. That's an option. It works. But let me give you another option here. What if we separate this into actual three functions? Right? Call this f, call this g, call this h. What then can we do? Well, it turns out we can still use the product rule. The product rule actually works not just for two functions multiplied. It actually works for three functions multiplied, or four functions multiplied, or 17 functions multiplied. It looks like this. For the product rule, if I have k of x equaling f of x times g of x times h of x, right? Three things multiplied. Then k prime of x is f prime of x, and then the other two just stay. Plus, this time, the g gets the prime, and the f of x and h of x stay. Plus, the third time, the f and g stay, and the h gets the prime. Basically, one of the functions gets the derivative multiplied by the other function's not derivative each time, and those terms get added together. So we have the f prime times g and h, plus the f and h times the g prime, plus the third term there, h prime times the f and g. And that is the product rule just now with three functions. Let's try that out with our example. We have 3x squared times cosine of x times sine of x. Let's consider the 3x squared as like my f function, the cosine is like my g function, and the sine is my h function. Then k prime of x is the derivative of the first, that's 6x, leave the g, leave the h. Plus, leave the f function 3x squared, the derivative of g, cosine, the derivative of cosine is negative sine of x. Leave the h. Plus, leave the f function, leave the g function, derivative of h, the derivative of sine is cosine. And we have 6x cosine of x, sine of x, minus, because the negative sign there, minus 3x squared sine squared of x, plus 3x squared cosine squared of x. And it looks like the only thing we can factor out here is a 3x. That'll be 2 cosine of x sine of x minus x sine squared of x plus x cosine squared of x. Which is a great answer. Be very happy with that. I will say we could actually use some of those double angle formulas that we talked about from trig a little bit more here. They're helpful to know. Remember that cosine of 2a, I said, I think in the last video, has three different functions that it could be. Oops, sorry. The cosine of twice an angle is the cosine squared of an angle minus the sine squared of that angle. The cosine of twice an angle is also 2 times the cosine squared of an angle minus 1. It is also 1 minus 2 sine squared of an angle. There's three different versions of cosine of 2a that we can use, and that is helpful for us. The sine of a double angle has only one identity, which is 2 sine A cosine of A. But if you look at our problem that we just created here, we have a 2 sine x cosine of x. 2 sine of x cosine of x, that's like this right here. 2 sine A cosine of A. 2 cosine x sine of x. That is the sine of twice the angle. So if we wanted to, we could say this is 3x times the sine of twice the angle, the sine of 2x. Minus, and then if you look on the two right terms here, negative x sine squared of x plus x cosine squared of x, we could factor out a negative x inside of the parentheses here. So then I'd have, actually I want to factor out a positive x. That'll give me cosine squared of x minus sine squared of x. If I just change the order, do the cosine first. Cosine's positive, cosine squared is positive, sine squared is negative. And we see that right over here, this cosine squared minus sine squared is the same as cosine squared of A minus sine squared of A, which is the cosine of 2A. And we get this, 3x sine 2x plus x cosine 2x, which some might argue is more simplified. Okay, so the big picture here, though, other than that last simplification, and I try to bring those in every time I can because I'm trying to get you to remember these double angle formulas over here and to use them. But the idea is we can do, if we have 3 functions multiplied, we can still do the product rule like this here. Okay, so that was more on the product rule. Let's try more on the quotient rule. All right, the more on the quotient rule is not going to feel like quotient rule at all. More on the quotient rule. One idea is some people, and this is real, some people never use the quotient rule. Don't use the quotient rule. Now, I kind of split this, where sometimes I'll do this next thing that I'm going to show you, and I take a quotient rule and I rewrite it and I don't use the quotient rule. But sometimes I just think it's easier to go ahead and use the quotient rule. So I kind of do both. But there are people out there who say they will never use the quotient rule, they will always do the thing we're about to learn now. Instead of writing it as a quotient rule, we could always write it as a product rule. Let me give you an example. If I have h of x, let's write what I just said there. So don't use the quotient rule. Instead, rewrite it so that you can use the product rule. And actually, it's not just the product rule. It will be the product rule and chain rule combo. Kind of together, product rule and chain rule. Okay, so don't use the quotient rule, instead rewrite it so that you can use the product rule and chain rule. Here's the idea, here's an example. Let's say we have h of x, and let's do a quotient rule. That is 3x over, let's do 5x plus 2 squared. Definite looking chain rule, product, wow. Definitely a quotient looking problem. I'll get it right one of these times. Definitely a quotient looking problem. And we could absolutely do the quotient rule. In fact, let's do the quotient rule just to make sure our answers are the same. All right, so h prime of x, this is regular quotient rule, is the derivative of the top, that's 3, times the bottom, 5x plus 2 squared. Minus, leave the top, 3x. The derivative of the bottom, now we'll have to do chain rule here, so we'll bring the 2 down, times 5x plus 2 to the first, times the derivative of the inside, 5x plus 5x, look bad, plus 2 to the first. The derivative of the inside multiplied by g prime is, the derivative of 5x plus 2 is 5. All over the denominator, 5x plus 2 squared. if you square, you get a fourth power. Okay, so here we have 3 times 5x plus 2 squared minus 3 times 2, 6 times 5, 30x times 5x plus 2 all over 5x plus 2 to the fourth. And what you should see in the numerator there is you could actually factor out a 5x plus 2 term as well as a 3. In which case we have just one 5x plus 2 left in the first term and then minus 10x in the second term divided by 5x plus 2 to the fourth, which we can then see that the 5x plus 2 here in the numerator cancels out with one of them in the denominator, and we have a final answer of 3 times. All right, if you were to combine inside this bracket, you have 5x plus 2 minus 10x. 5x minus 10x is negative 5x plus 2 over 5x plus 2 to the third, which it almost looks like you could cancel out another 5x plus 2, but because of that negative sign, you can't. Even if you factor out a negative sign and called it negative 3 here, that would be a 5x minus 2, and that does not cancel out with a 5x plus 2. So something like that is regular quotient rule, doing it how we always have. But let's try to not use the quotient rule, right? Let's try to instead turn into a product. So when we had our function, I believe it was h of x equals 3x over 5x plus 2 squared. Let's bring this 5x plus 2 squared up into the numerator so that it's a product. And all that does then is change it from 5x plus 2 to the positive 2. When I bring it up to the top, it becomes 5x plus 2 to the negative 2. This is 3x times 5x plus 2 to the negative 2. This is what people do all the time. And they're like, okay, now I just have a product. I have a product here times that. I have a f function 3x, a g 5x plus 2 to the negative 2. Now, instead of doing the quotient rule, I could just do the product rule, h prime of x. The derivative of the first is 3, and we will leave the second, 5x plus 2 to the negative 2. Plus, we will leave the first, 3x. Now we'll take the derivative here. Now we're bringing down this time negative 2. And be careful here, it's 5x plus 2 to the power of negative 3, right? Negative 2 minus 1, negative 3. Then times the derivative of the inside function, the derivative of 5x plus 2 is in fact 5. So here we have 3 times 5x plus 2 to the negative 2 minus 30x, that looks familiar, 5x plus 2 to the negative third, which is a fine answer. It's correct. But if you want to show that it's the same thing as what we had up here, here's kind of a nice trick we can do. When we want to we have negative coefficients here in our numerator. Let's put this over 1. Think of it as a fraction, right? Anytime you have negative coefficients in your numerator, what you can do is multiply by whatever term that is to the same number, but this time positive. And you're choosing the most negative one we have. We have a negative 2, we have a negative 3, so we'll do the 3. It's the most negative. So we'll do, instead of 5x plus 2 to the negative third, we'll multiply that by 5x plus 2 to the positive third, top and bottom. Like that. And because you have a minus sign in the middle here, this gets distributed to both. So when I do this, 5x plus 2 to the 3 times 5x plus 2 to the negative 2, you add those together. Negative 2 and 3 is just 1. And so you get 3 times 5x plus 2 to the first. Right? 3 and negative 2 makes 1. Now when I do this to the second term, 5x plus 2 to the third times 5x plus 2 to the negative third, you add those. Negative 3 and 3 is 0. Anything to the 0 is 1. And so all you have left is minus 30x over 5x plus 2 to the third. And if I combine those, I get 15x plus 6 minus 30x over 5x plus 2 to the third. That is negative 15x plus 6 over 5x plus 2 to the third. And because negative 15 and 6 both divide by 3, maybe even negative 3, if I factor out that negative 3, I have 5x minus 2 over 5x plus 2 to the third, which is the same answer that I had before. Now, if you don't do all the simplification, just getting to, say, right here, I think is a little bit shorter. Maybe a little bit more direct than using the quotient rule. But either way, you can use the quotient rule all you want. You can turn your quotients into products and use the product rule. I just wanted you to be aware that this is something you can do that might be helpful at times.